Now, if we want to use an item from our inventory, the following will happen. We'll go onto the actual bottom box, okay? So essentially, the first thing we do is we check that we have an item, a reference to the item to delete. If we don't have a reference, we'll skip and we'll directly go to maintaining the size of our horizontal box. We don't need to do anything really, we just need to maintain the size of our horizontal box because we haven't deleted anything. If we do have an item to delete, the output will be is valid, and we'll go into this branch. Now, in this branch, just like in the situation that we had in case we were adding items to the inventory, we are checking that the item to delete is equal to the item to delete previous. So if the item to delete is different from the item to delete previous, so let's say we didn't have any item to delete previously, or we had let's say a different item to delete previously, then what happens is that we will go onto the false boolean, and what will happen is I set the item to delete previous as my item to delete, or well, I set, basically I feed it this reference, and then I play an animation, which is the blend out animation. So I start blending out the object, still when the size of the scale box and horizontal box have not changed, okay? So as you can remember in here, we have this situation, and I'm using, let's say, my first or my second object, it doesn't really matter. What happens is that before changing the size of my scale box and my horizontal box, which will have to be decreased horizontally, both of them, what I do is I play the blend out animation, so that first the image will slightly go from an alpha of 1 to an alpha of 0, so I don't see it anymore, first of all. Okay, nothing else changes at the beginning. This is what I do in these boxes. And as you can see, there's nothing else I do. I play the animation and I do nothing else. Okay, I do nothing else. Next, what happens is that on the next frames, remember this code runs every frame. So on the next frame, we'll have a situation in which the item to delete will be the same as the item to delete previous. So we will get a true here out of this boolean. We get a true, and we go into this branch. This branch checks if the animation is playing, the blend out animation is playing. As long as the blend out animation is playing, nothing will happen, because there is nothing that comes out of the true boolean, okay? So essentially this code will wait. It will wait until the animation is finished. Once the image is fully blent out, so it went completely transparent, so you cannot see it anymore, then this branch will output false, because the animation is not playing anymore, and we'll go onto this set size. Now, this set size works exactly the same way as I showed you before on the upper box, where we were in the case in which we were adding an item to the inventory. It works in the same way, but in reverse. So what that means is that, as you can see here in the lerp, instead of lerping from a box value that is probably 0 or very low to 1, we're actually lerping from a box value, a scale box value, or an image value, that the size I'm talking about, that is 1 to basically a value that is 0, using an alpha, okay? So we're slowly decreasing the size of our scale box here, okay? And this will happen every frame. Now, something important to keep in mind is that as long as the box is larger than 0.05 in size, okay, this branch will output false, which means that as long as the box is still relatively large, it hasn't reached really a value of 0, what I'm doing is I'm decreasing its size, and at the same time I will decrease the size of the horizontal box, okay? Together at the same time, the same way, if you remember, here I was increasing the size of the scale box and the scale of the scale of the horizontal box at the same time to maintain the size of the original item that I had in my inventory. And now I'm doing the same but in reverse. I'm decreasing the scale or the size of my horizontal box, and at the same time the size of my scale box. Now, the moment I reach a point where my scale box is very, very small, in this case I use the value of 0.05 in terms of size, then the branch will output true. And when the branch outputs true, it goes here. What happens here is that I take that box, I take that scale box, I remove it from the parent, so I essentially remove it from the horizontal box, okay? So essentially what I will have a situation in which I've got my first item, which has not been used yet, my second item, which has reached a value of a size of 0.05 or less, and at this point, my code, what it does is it removes or it unparents this scale box from the horizontal box, which is the black one. Okay? This is what actually happens. Sorry, I keep on getting notifications. It's very annoying. This is what actually happens. Now, what I do here, I also set my, but this is something outside the scope of this code, I also set my pick or used to true, because it means, at this point, it means that I've essentially used my item and this branch can go back to the top part, to run in the top part. Essentially, it's gonna idle in the top part. It's not gonna add any items in the top part. As I showed you before, it's gonna enter and it's gonna skip the it's probably gonna skip directly to maintaining the size of the horizontal box. Okay, and then once I do this, yeah, as you can see here, I go back to setting the size of my horizontal box essentially. So this is the bottom part. It's fairly easy. I think it's probably a bit easier than the top part. Once you understand the top part, you also kind of understand the bottom part because they're very similar to each other. And next we'll move on to the horizontal box sizing. Now, the last box for setting the horizontal box size and position is fairly simple. It's, I think, the simplest one of the three. And it does exactly what I said, basically. So the first thing it does is it sets the size of the horizontal box, and next the position, basically. So these are the only two things it does. Now, for setting the size, what I do is I take a reference to my horizontal box. I take the canvas slot of that. Well, so what does that mean? If I go back into the designer and I select my horizontal box, you can see that it has got a canvas panel slot. So this is the component we are targeting, and this is the size that we're targeting, basically size X. So essentially, if I go back to the graph, you can see that I take the canvas slot component, I get the size, which returns a vector 2, I convert it to a vector 3 with component of Z0, because we don't really care about the Z component, we only care about the horizontal component, basically the X component. Then what I do is I lerp, and this is a tricky bit, which is a bit out of the scope of this video, but essentially what I do is I lerp the current size, current X vector of my horizontal box to a X vector which I define in this inventory size. Now, how do I define the inventory size? The inventory size, I define it in a separate script, and the way I define it is basically I take the size of the scale boxes. So to give you an example, imagine that I have I've got one scale, that I've got one scale box. Now this will have a certain size in X, okay? If I've got two scale boxes, they have, my horizontal box will need to be obviously much larger. So in case of one scale box, this will be the horizontal size of my horizontal box. But in case I have two items in my inventory, this will have to be the horizontal size. Okay, so the calculation of the horizontal size, I do it in a different script. I just check how many of these items I have in my inventory, and since the size of this item, the size of these images is all the same, what I do is I say, okay, if I only have one item and the size is, let's say 5, then my inventory size will be 5. If I've got two items and each item has got a size of 5, then obviously my inventory size will be 2 times 5, which is 10. It's as simple as that. Okay, this is what I do. I check how many items I have in my inventory to calculate the size. Okay. Obviously, on top of this, you have to remember that there is the whole this thing blends, is not a direct size, so I might have to, so this thing lerps basically, so it will lerp from the size, for example, of one single image to the size of two images, and the way it lerps is it lerps at exactly the same speed as my scale box or my image is getting resized. Okay, so if you remember once again here, when I was saying I'm increasing the size of my horizontal box at the same rate as my scale box, that's what I do essentially. Okay, so as you can see, I've got a speed multiplier inventory, and this is getting multiplied by the delta time, so the time of the taken by the frame to actually being displayed, being processed. And this speed multiplier inventory times the delta time is exactly the same as in here. So as for my scale box, as for my images, when I add it to the inventory, and it's exactly the same as this one for when I remove one from the inventory, so that everything will be essentially coherent. Okay, I will not get changes in size which will cause distortion in my images thanks to this. And once I do the lerp, the final value of the lerp is a vector. I take this vector, I transform it back to a vector 2, and I feed it to the set size of the canvas panel slot, which will resize my horizontal box. Okay. After that, I have to set the position of the horizontal box. As I told you before, as I showed you before, we need to recenter the horizontal box, because if we keep it here, if we keep the origin at the center of my canvas, it will keep on increasing its size only on the right. Okay? So we will get all the images on the right, and it will be skewed, and it will look like, it will not look good, basically. We want it to be centered, or at least in my case, I want it to be centered for aesthetic reasons. Having said this, how do we set the position? Well, once again, I take the horizontal box, a reference to the horizontal box. I take the canvas slot of my horizontal box. I take the position of my canvas slot. And then what I do is I once again transform the position to a vector 3 so that I can use it inside lerp. And I'm going to lerp the position from the my current position to a calculated position. Now, the calculated position is once again something that you will have to do outside of this, that I do personally outside of this let's say logic. I can show you later how I do this very quickly, but I'll do it at the end of the video so that maybe you get a bit of understanding roughly of how the position gets calculated. But this is essentially, once again, something that I do based on this size. Okay, so once I know that I have two objects, two images inside my horizontal box, and I have a size of 10 for my horizontal box, then it means that I need to center it. I need to center my horizontal box at 5, basically. Okay. So what I do is I move my horizontal box -5 units on the x-axis or on the x to the left, basically, right? So -5. So that essentially I've got, yeah, if this starts, at -5, then the center roughly will be at 5, and this will be at 10. The rightmost part here will be at 10, so that we've got it exactly centered for two images. And this is a calculation that you have to do every time you add or remove an image, basically. It's not a difficult calculation, it's just that you need to do it, yeah, and if you want this smoothness, basically, and if you want to adjust for the position. And that's it, basically, guys. So it's a bit of it's annoying. It's a bit of a spaghetti code, this one. As much as I tried it, I tried to isolate every single let's say function, but it works fine. And as of now, I think it's quite robust. I think I've tried to break it in several instances, but it worked all right in most cases, basically. So thanks for watching, and see you next time.